In medicine, everything is a balancing act. It's like this constant search for the Goldilocks zone for every single drug. We need a dose that's strong enough to actually work, but not so strong that it starts causing problems. So, how on earth do scientists figure that out? How do they find that perfect dose?
And that really is the million-dollar question in pharmacology, isn't it? Answering it isn't as simple as just finding one magic number. It's about understanding risk for a whole population of people. So, okay, where do we even start? Well, first things first, you've got to have a way to measure a drug's effect, right? And there are basically two ways to look at it. There's what's called a graded response. Think of it like a dimmer switch. It measures how much something changes in one person, like how many points your blood pressure drops. But for our story today, we're focused on the other type, the quantal response. This is more like a light switch. It's either on or off. It's a simple yes or no. Did the headache go away or not? This all-or-nothing approach is absolutely key for figuring out safety across big groups of people. All right, so to really get a handle on drug safety, we need to establish two key benchmarks. One tells us how well the drug works, and the other tells us when it starts to become harmful. These are the absolute basics, the building blocks of this whole field. Okay, first up is the median effective dose, which has the catchy name ED50. All this means is it's the dose that gets the job done, say getting rid of a headache, in exactly half the population. It's our yardstick for how effective a drug is. And of course, there's a flip side to that coin. This is the median toxic dose, or TD50. And you can probably guess what this is. It's the dose where 50% of people start to feel a specific toxic side effect. So this becomes our benchmark for harm. Now, taking that to its most extreme conclusion, you get the median lethal dose, or LD50. And yeah, it's exactly what it sounds like. The dose that's fatal to 50% of a test population. And it should go without saying, this is something determined in lab studies with animals, never with people. So where did this whole idea of using the 50% mark come from? Well, we can thank a pharmacologist named J.W. Trevan way back in 1927. See, before him, the terminology was kind of messy. People would talk about a minimal lethal dose. But what does that even mean? It could be anything. Trevan was the one who said, look, we need a standard, something statistically sound that everyone can use. And to develop this idea, he did some pretty groundbreaking work. I mean, get this. He analyzed data from 370 mice that were injected with cocaine. That painstaking research is what gave us the LD50, one of the cornerstones of modern toxicology. Okay, so now we have our two building blocks, the dose that helps half the people and the dose that harms half the people. The next logical step for scientists was to try and mash those together into one simple number that could tell you, at a glance, how safe a drug is. And that brings us to something called the therapeutic index, or TI for short. The concept here is really straightforward, almost elegant in its simplicity. You just take the toxic dose, the TD50, and you divide it by the effective dose, the ED50. Let's make that real. Say a drug becomes toxic at around 100 milligrams, but it's effective at just 10 milligrams. You do the math. 100 divided by 10, that gives you a therapeutic index of 10. The logic here feels solid, right? The bigger that number is, the wider the gap between the helpful dose and the harmful one. So a bigger TI has to mean a safer drug, right? Well, not so fast. It's so tempting to rely on a single, simple number. But sometimes that simplicity can hide some really serious dangers. And it turns out the therapeutic index has a massive hidden flaw. Let me ask you this. Let's imagine we have two totally different drugs, but they both have the exact same therapeutic index. Let's say it's 10. Does that mean they are equally safe? What do you think? The answer is a huge, emphatic no, and here's why. The TI only looks at that one point in the middle, that 50% mark. It tells you absolutely nothing about the slope of the curve. It doesn't tell you how fast a drug goes from being helpful to being dangerous. And that little detail, well, it changes everything. Think about it like this. One drug might have a really gentle slope. You can increase the dose to help the toughest cases, and you're still in a safe zone. But another drug might have a toxicity curve that's more like a steep cliff. The dose you need to help 99% of people could already be pushing a dangerous number of people right over the edge into toxic effects. And the therapeutic index, it would be completely silent about this danger. It wouldn't warn you at all. So once scientists realized this huge blind spot, they knew they needed a better tool.
something more cautious, something that was actually designed to protect the most sensitive people in the population. And that's where the margin of safety comes in. The whole idea here is to be way more careful. Instead of just looking at the 50-yard line, it looks at the opposite ends of the field. It compares the dose that's toxic to just the most sensitive 1% of people with the dose needed to be effective for 99% of people. As you can imagine, that is a much, much stricter test. So you can really see the difference here. The therapeutic index is fine for a quick general overview, maybe for early stage screening, but the margin of safety is what you need for the real world. It's conservative, it's cautious, and by focusing on those extremes, it does a much better job of assessing actual clinical risk. Its whole purpose is to make sure the dose that helps almost everybody doesn't accidentally harm even a small number of people. Okay, so the margin of safety is clearly a huge improvement. But here's the thing. The search for a single perfect number that can guarantee safety for everyone, it's just not possible. Why? Because human biology is incredibly, beautifully, and sometimes frustratingly complex. I mean, the reality is some side effects are just plain unpredictable. They're what we call idiosyncratic. Some bad stuff might not show up for years, even decades. And then you've got things like a severe allergic reaction, which isn't about the size of the dose at all. And this is the most important part. The perfect dose for the average person might not be the perfect dose for you. So what's the big takeaway here? It's that these metrics, both the therapeutic index and especially the margin of safety, are absolutely essential. They are powerful guides that help doctors and scientists understand and manage risk. But that's what they are, guides. They aren't crystal balls. They can't promise 100% safety. And that leaves us with a really important final thought. If we know that every number has its limits and that every one of us can react differently, how do we trust the medicines we depend on? It's a huge question, and the answer isn't simple. It's about that delicate balance between powerful science, the experience and judgment of doctors, and just constantly being watchful.